In this section, we're going to talk about antiderivatives and indefinite integrals. Suppose we want to know the integral of x dx, x to the 1 dx. That is, so now, whatever it equals, when I take the derivative of it, I should get back x. Okay, because the antiderivative undoes the derivative. Well, when you take the derivative of, say, x cubed, let's not worry about the number in front yet, but the power goes one less. If you have, I don't know, 7x to the 14, I don't care what's in front, but the new power becomes one less. So when you integrate, the power is going to become one more. So a good guess for this would be x squared. At least that's the start. Now, whatever it equals, the derivative of this better be x. Well, the derivative of x squared is 2x. But I want x. Oh, let me divide by 2. There it is. The derivative of x squared over 2. The derivative of x squared over 2. That's their antiderivative. Why? Because if I take the derivative of that, I'll get x. And you know what? When it comes to integrals, you can add any constant you like. We just add an arbitrary constant because the derivative of this is x and the derivative of that is 0. So yeah, I get back x, which is what I wanted. Okay, well, what do you think the integral of x to the n dx? For now, we'll say for any n. Well, again, the power is going to have to be one more. Because I know one thing, the derivative of that will be n plus 1, but most importantly, times x to the n. Because if you have n and then you add 1 and you take away the 1, you're back to n. But I don't want that. Oh, I get it. I will divide by n plus 1. Now, when I take the derivative of that, which I'll do down here, that constant stays where it is. I bring down the power, then I make the new power of x one less. And look at that. That cancels out, and I get x to the n, just like I'm supposed to get, plus any constant. And as I said, we'll talk in a moment, and that moment is now, about whether or not there's any restrictions on n. Well, you can't divide by 0, and you'll be, you can't divide by 0, and you will be dividing by 0 if n is -1. So for this formula, n cannot be -1. That is, the integral of x to the -1 is not, like the rule says, add 1 to that power, and then which is 0, and then divide by that power. That would be 1 over 0, which is complete nonsense. Okay, so as long as that exponent is not -1, here's our answer. Add 1 to the exponent, divide by that new number. So, if you had, for example, the integral of the cube root of x dx, first I would rewrite this. There's an understood 1 here, and that 1 gets divided by that number. And the rule says you add 1 to that power. Now, if you have a fraction and you add 1, you should think of the fraction as b over b, because now we have common denominators. So we keep it. The numerator is a plus b. Now, how can we just go from a over b to there? Oh, you add the a and the b, that's the numerator, and then keep the same denominator. Okay, I get it. I add the 1 and the 3, I get 4, and I keep the same denominator. And I also divide by that number. 4 over 3 plus a constant. Suppose you have the integral of 7x to the 4th dx. Well, this 7 just comes along for the ride. Add 1 to the power, divide by that power. Think about it. When you take the derivative, the 5 comes down, is going to cancel with the 5 in the bottom, leaving the 7, and the new power, the x stays, the new power will be 1 less than 5. But don't forget, for every integral, you can add plus c. You're going to lose a point on every integral you solve if you don't write the plus c. So if you have the 10 integral question test and you do everything right except you don't write plus c, you lose 10 points. You went from 100 to a 90. I call that suicidal. Okay, so suppose you have the integral of dx over the square root of x. Dx over the square root of x. Now we only know how to take the integrals of x to the n dx's, and only then n has to be other than -1. So we don't know how to do this integral the way it is. So maybe I can rewrite it. Well, x to the square root of x is x to the half. Oh yeah, I can bring the x to the numerator as long as I change the power, dx. The answer is, well, -1 plus 2, that's 1, divided by 2, and then divided by that power, 1 over 2. And dividing by 1, you don't need to do, plus c. And if you don't believe that's right, take the derivative of it, and if you do not get 1 over the square root of x, or something that equals 1 over the square root of x, I made a mistake. But let's check it. If you take the derivative, you bring down the power, half times 2 is 1, times x, you make the new power 1 less. If I put the x in the bottom, it's plus a half, and yeah, x to the half is square root of x, 1 over square root of x. And the derivative of c is 0. So let us do this problem. Okay, little bit of algebra. Suppose you have dx over 2x cubed. Well, this is equal to the integral of dx over 2 cubed times x cubed. So that's the integral of x to the -3 dx over 8. So there's the over 8. Add 1 to that power, get -2, and then divide by that new power. So there's an understood 1 here. So the fraction is the number is going to be 1 over 16. Sorry, -1 over 16. And I'm going to bring the x to the denominator. And there it is. That's the antiderivative of this. Or it's the integral of that. Whatever you want to call it. Now, suppose you have this integral. The integral of x to the 5 halves plus 2x to the 3 halves minus 3x to the 1 half plus, I don't know, 4x to the negative a half, all dx. Now, just like when it comes to taking the derivative of or sum and difference, you take the derivative separately, you can do the integral separately. The integral of that is, well, you add 1 to the power. 5 plus 2 is 7 over 2, and then you divide by 7 over 2. 7 over 2 plus the 2 stays. You add 3 plus 2 is 5 over 2. Then you divide by that number. 5 over 2 minus, there's this 3, x. You add the 1 and the 2, you get 3 over 2, and then you divide by 3 over 2. And in that case, the 3's cancel. Plus 4. You add 1 to that power, you get a half. So you divide by 1 over 2. Dividing by 1 you don't have to bother with. Plus c. So the only changes I would make is I would call that 4, and I wouldn't write this. Oh, and I would call that 8x to the 1 half. That is, this is 2x to the 7 halves over 7 plus 4x to the 5 halves over 5 minus 2x to the 3 halves plus 8x to the 1 half plus c. If you take the derivative of this, and I didn't make any mistakes, you will get that back. If you don't, either you took the derivative wrong, or I made a mistake, or possibly we both made a mistake. I did the integral wrong and you took the derivative incorrectly. Okay. Now, suppose we have this integral. X to the x cubed plus 2x squared minus 3x plus 4 all over the square root of x dx. Now, we only know how to take the derivative of x to a number. And even if there's a constant, we know how to do it. The derivative of x to the n, well, that's x to the n plus 1 over n plus 1. The constant just tags along, plus c. But here we have a fraction where the numerator and denominator has x's. So we need to do something with this. You have x cubed plus 2x squared minus 3x plus 4 all times dx over x to the half. So we do what's called division. We divide this by that, which means we subtract the powers. 3 is 6 halves, minus 1 half is 5 halves, plus 2. 2 is 4 over 2, minus 1 over 2 is 3 over 2, minus. The power is understood to be 1. There's the 3. 1 minus a half is a half. Here, you can think of this as 4x to the 0. And then when you subtract the powers, 0 minus a half is negative a half. Or you can bring this up as x to the negative a half. No matter how you do it, this is what we want to integrate. So now we add 1 to that power. 5 plus 2 is 7 over 2. And then you divide by 7 over 2. Plus. Okay, this should be x, I guess. Yeah. Sorry. You add 1 to that power by adding the 3 and the 2 and then dividing by 2. So then you get 5. You have to divide by that power. 5 over 2 minus 3. You add 1 to that power, you get 3/2, and then you divide by 3 over 2. And the 3's happen to cancel. Plus 4. You add 1 to that power, you get 1/2. Then you divide by 1 over 2. Plus c. And then we can clean it up a little bit. You get 2x to the 7/2 over 7 plus 2 times 2, x to the 5/2 over 5 minus the 3's cancel plus 8x to the 1/2, and there's no point in dividing by 1, plus c. Plus c. Okay. Now, suppose you were given this problem. The integral of x plus 3 times 2x minus 5 dx. Well, if you FOIL it out, you'll get 2x squared minus 5x plus 6x, so that's plus x, minus 15. Okay, and that's equal sign is definitely right, because all I did was replace this with something that it equals. And I'm still taking the integral of it, and I'm still multiplying it by dx. So I get 2x to the 3 over 3. Doesn't understand 1 there, so I get x squared over 2 minus 15x plus c. The derivative of a constant is 15x. Sorry, the integral of a constant is kx. Well, if you think about it, the derivative of a constant times x, not a negative constant, the derivative of a constant times x is a constant. Therefore, the integral of a constant is kx plus c. Okay. So the integral of negative 15 was negative 15x. And there's no way that that answer's wrong. Now, the question is this integral, can you take the integrals separately? Can you take the integrals separately and then multiply the results? Well, the integral of x is x squared over 2 plus the integral of 3 is 3x. Now then you have a constant. Or maybe you only put the constant at the end. Let's not complicate it. It's not going to work anyways. The derivative, then the integral of 2x is x squared minus the integral of negative 5 is negative 5x. Now, the thing is, when you multiply this, you're going to get an x to the 4th over 2. And already I can see that's wrong. And nowhere are you going to take away x to the 4th. For example, this product just gives you an x cubed. This product gives you an x cubed. And that product gives you an x squared. You are only getting x to the 4th from that, plus other stuff. It's not going to equal that. You can't, the integral of a product, the integral of a product, we had a product here, is not the product of the integrals. And the reason that makes no sense as well is the integral of f of x dx. Well, f of x is 1 times f of x, right? So this is the integral of 1 dx whatever that is, times the integral of f of x dx. And the integral of 1 dx is x times the integral of f of x dx. So the integral that we started with is x times that integral. But you know what? This integral, f of x, is 1 times f of x dx. So there's this x, and now I could write this integral as a product of integrals, if I could. It's 1 dx times the integral of f of x dx. But this first integral is x. Times that x in front, we get x squared times, I did x times the integral. So again, I end up with the integral that I started with times x squared. And if I did this again, if I said there's a 1 here, 1 times f of x, I can get x cubed times the integral of f of x dx. But no. That's absurd. Okay, you can't, this does not equal to x to the n, the integral of f of x dx for any integer n. That's not true. You can't do this. You cannot do this. No, it doesn't work. So, for right now, what you can do when you have a product, until you learn another technique, if you have the integral of a product, you could multiply it out. You could multiply it out. Now, let us look at this one. We'll look at two problems. They're going to look real similar. The answer is going to be pretty much exactly the same, except we're going to have t's on the right. So it's dt. You add 1 to the power, divide by that number. There's an understood 1 there. You add 1 to the power, you divide by that number. And the integral of a constant is that constant times the variable. The variable is x, so plus 4x plus a constant. Over here, we're taking the derivative with respect to x. Here we're taking the derivative with respect to t. So we'll get t to the 4 over 4, add 1 to the power, divide by that power. The integral of a constant is a constant times a variable plus a constant. Okay, the only difference between the left side and the right side is everywhere we saw an x on the left side, we have a t on the right side, and everywhere on the right side we have a t, we have an x on the left side. It's the only difference. Okay. Now, suppose we do a couple of more problems. Suppose I ask you to find, doing integrals, find y if dy dx is 3x plus 5. That means we want to integrate. We want to undo the derivative. If you undo the derivative of dy dx, you get y. Because if you take the derivative of y, you get dy dx. So I need to integrate the other side. Now whether you write it or not, that's up to you. But y is going to be 3x squared over 2 plus a constant times the variable x plus a constant. Okay. Now, here's a good problem. dy dx is equal to 5x to the fourth plus 4x cubed. You're told that f of 2 is equal to 7. Find y. Well, if I integrate this, if I do the antiderivative, if you take this as take the derivative of y. Okay, you take the derivative of y. And I say, oh, I made a mistake. Undo that. So you're going to get back y. And if I say, undo the derivative on the right side, well, I have to undo the derivative on both sides. That means for the right side, the best terminology would probably be integrate. So y is equal to x to the 5, because the 5's cancel out, plus x to the 4, because the 4's cancel out, plus a constant. What's this? Well, y of 2 must be 7. Well, y of 2 is 2 to the 5th plus 2 to the 4th plus c. It's 32 plus 16 plus c. It's 48 plus c, but it must be 7. Oh, c must be negative 41. That is y, updating this, y is equal to x to the 5th plus x to the 4th minus the number 41. Okay. Let us do 2 more problems. New type. Okay. Problem is to find f of x. And you're told that f prime of x is equal to 3, f prime of 2 is 1, and say f of 0 is 7. And you want to find f of x. Well, if I undo taking the derivative there, I would get f prime of x. If I undo the derivative on the right side, I'll get 3x plus the constant. Oh, when I plug in 2, it's supposed to get 1. That'll help me solve for c. So f prime of 2 is equal to 3 times 2 plus c, which is 6 plus c, which is 1. So that implies c is negative 5. Okay, let me update this. F prime of x is 3x minus 5. But again, they want me to find f of x. Well, if I undo the derivative here, oh yeah, I'll get f of x. Because if I do the derivative here, I'll get f prime of x. So I have to undo the derivative here as well. So I get 3, x squared over 2 minus constant. Undo the derivative, you get the constant times x plus an arbitrary constant. Ah, that's why they told me what f for 0 is. On one hand, f for 0 is c, because if you plug in 0 there, you get 0, and there you get 0. 0 minus 0 is 0, plus c is c. On the other hand, f for 0 is 7. Ah, c is 7. So I update this. So that f of x is equal to 3x squared over 2 minus 5x plus 7. There it is. And now I can check, make sure everything works. F for 0, yeah, that's 7. And the derivative would be 3x, the 2's cancel, minus 5. And the derivative at 2. 3 times 2 is 6 minus 5 is 1. Yeah, look at that. The derivative is 1. And if that's f prime, my goodness, this works. F double prime of x is 3. So that worked. Okay. My f of x that they asked me to find, and I did find, lives up to the second derivative is 3, f prime of 2 is 1, and f of 0 is 7. Pretty neat. Now, suppose they give you the following. Again, find f of x. They tell you that f double prime of x is 6x. They tell you f prime of 1 is 3, and f of 0 is 4. Okay, well, if I undo the derivative, I'll get f prime of x on the left, and on the right, I'll get 3x squared plus a constant. Ooh. F prime of 1, which is 3 times 1 squared, which is 3, plus c, that's supposed to equal 3. Oh, so c is 0. Okay, so f prime of x, I'm just updating this, is equal to 3x squared plus 0, which is just 3x. Now, if I undo the derivative here, I'll get f of x. And if I undo the derivative there, I'll get x cubed plus a constant. Well, f of 0 is equal to 0 cubed, which is 0, plus c. On the other hand, I'm told it equals 4. So c equals 4. And I update f of x with that new information. It's x cubed plus c, which is 4. And we can verify this. I never understand why students will leave an exam and you ask them how they did and they don't know. They don't know. How don't you know? Check your work. Even if you fail. No, I checked all my answers and, they didn't check out. I don't think I did very well. Okay, let us take the derivative of f of x. So we get f prime of x is 3x squared plus 0. Okay, well, first of all, let's check the first thing that we should have. Sorry. F of 0 is 0 cubed plus 4, which is 4. Got it. F of 0 is 4. Now, f prime of x is 3x squared. And f prime of 1, well, 1 squared is 1 times 3 is 3. Oh, my goodness, I got that. And the second derivative, that is the derivative of 3x squared, is 6x. Wow, I got it. If this is 10 points, I know that I got the 10 points. And it wasn't that hard to check. If you didn't get all 3 of these, and you couldn't find your error, well, you know you lost some points. Hopefully not too many. Okay. Let us try one more. Little twist here, but not anything major. Suppose you come to know that dy dt is equal to 6t squared minus 4t plus 2. And they tell you that y of 0 is 4, and to find f of t. Find f of t. Okay. So you're given the derivative and you want the original function, which is called y. You took the derivative of y. Well, if you undo the derivative, you'll get y. And if you undo the derivative here, you get 3t squared minus 2t squared. Oops. 2t cubed. Sorry. So you get 2t cubed minus 2t squared plus 2t plus a constant. And y of 0, well, you plug in 0 and 0 and 0. You keep getting 0 until you arrive at the constant. If the variable of a polynomial is 0, it's going to, the whole thing's going to equal to the constant. And they're telling us that y of 0 should be 4. That means the constant is 4. So with these two pieces of information, I know that y is 2t cubed minus 2t squared plus 2t, and c is 4. And, you know, they say find f of t. I'll call it f of t. But there it is. Okay, this is your first introduction to integration. Okay, learn this well. You're going to need it for other types of integration.